So hello everyone, this is the Promotory channel. I'm starting the assembly of this engine. This is an ISUZU 4HK1. So this engine was taken from this kind of equipment. Heavy equipment, an excavator, belonging to my subscriber from the Moscow region. The disassembly of this engine is on my channel. The link is in the description below this video. I'm starting the assembly. The engine block has already came back from the machine shop. I'll briefly tell you what was done. So first we checked the main bearing seats to make sure everything is fine here, because at least according to our machinists, the main bearing seats on this engine can't be restored, and I think it's probably because there's a one-piece bed plate here. The engine just splits in half. There are no separate caps. So we checked the main bearing seats and everything is fine. Well, and then as we remember, we had problems with the cylinder liner seats. One of them was in really terrible shape. So what did the machinists do? They bored out all 4 cylinder liner seats from their own blanks from other liners. They made these liners and installed them there, right on the spot. Put it again for the piston, gave the piston to the machinists. They also skimmed the cylinder head mounting surface. I think it was about 0.12 millimeters. They installed, pressed in and bored the liners, but now I see they're protruding a bit. I can't recall how much they should stick out, so I'll check the manual later. Well, I think it's 0.03 to 0.05 millimeters. So each liner has a protrusion just like it should be. We also took the head for machining. Here we replaced the injector sleeves. We also machined it. We removed 0.05 here, so just 0.05 millimeters in total. Well, that's because on this engine, there's a very small margin for how much we can remove from the block or the head, all because of this timing gear. So changing this height, whether on the block or the head, we lose the clearance in the timing gears. Well, I'll explain more about that later. We're going to use a thicker repair spec gasket here. We'll get to that. So, as usual, there's some machining work to be done. It took us quite a bit of time because, as usual, the machine shop has a backlog. The customer, the owner of this equipment, is already unhappy. Now, I'll explain briefly just so you have a basic idea. The owner of this equipment didn't contact me directly. He communicated with me through, well, also one of my subscribers who has already had 2 engines done by me. The subscriber who previously had engines done by me called me and asked, will you take an ISUZU 4HK1 engine for repair? I said, well, I'll take it, send it over. So while this was just a preliminary conversation for now, I thought there would be more clear and specific information later, like the timeline, the cost. They'd find out and discuss all that and so on. So that's it. And then he disappeared. This was around New Year's. Somewhere around March. I have a partner, Alexander, who says they're sending the engine and have spoken to you. But I remember that the conversation was about the ISUZU 4HK1, but nothing specific was discussed. Well, that's it. They're sending it. Basically, the engine is already at the transport company. The engine has already arrived, and now it needs to be picked up from the transport company. No one is contacting me. No one is asking me anything about the repair costs or the time frames. Well, they just presented me with a fait accompli. The engine was sent. The engine is already at the transport company, and it needs to be picked up. So we pick up the engine. I completely disassemble it and inspect it for defects. Since I don't have the owner's contact information, I send all the information to my subscriber who previously worked on the engines and through whom basically we got all this done. Then, after a few days, I don't remember how, but I get in touch with the owner of this engine. So I tell him the repair cost is 90,000, to which he replies, why 90? He says I was told 60, and I say, whoever quoted you that price can do the job. Well, the person who already disassembled your engine, I say, is the one. He used to work on engines back before the war, and now the war has been going on for 5 years. So much has changed. What about the deadlines? The person needs it very, very, very quickly. Faster, because the season is starting. The excavator is for construction site jobs, but this engine came to me completely out of turn. Like I said, well, obviously I can't just drop everything and work only on this engine. I was already assembling the main engine. I got a call from, well, basically a subscriber who had repairs done by me before. He said, please take it apart because we need to inspect it. It's for a good friend of mine. So basically I agreed, put away everything I had prepared for assembling the engine, moved the table, cleared the space and took apart this engine. Overall, it's a rather unpleasant situation. I've been going on about this for a while. Maybe I can't quite get my point across, but the point is, I was just told it was a done deal. No one talked to me about it. Not about the cost, not about the deadlines, not about any of those things, not about the conditions. Like, for example, we only work with our own parts. We don't work with customer supplied parts. And the customer, again, wanted to buy his own parts. So if I had talked to the owner of this engine and told him all my conditions, he might have just disagreed with some of them. And that would have been it. Everything would have ended there. So the owner of this equipment tells me over the phone, I already paid to ship it there and back. And on top of that, how much do I have to pay you for the repair? Well, I mean, I didn't ask anyone to send me the engine. I didn't persuade anyone. So basically, it was sent without any prior agreement, in fact. And then they set conditions for me, like you have to do this, you have to do that. I don't know. In my opinion, this is all absolutely wrong. So in the end, the customer is unhappy, meaning they're not satisfied with the price, how much the work costs, how much the parts cost. Then we had to take the block for machining work, but at first they quoted the price without the machining work included. Well, because there are no specifics, we need to find out everything. Understand what we're going to do with the block and how much it will cost. And then after some time, it became clear about the machining work, the cost, the timeline, and so on. So they told the customer the price again, this time including the machining work. To which he replied, now you're deceiving me. I have no way out now. So you're just going to add another 100,000 every day from now on. Overall, it's just an unclear situation. So the person wants it cheap, fast, and on his own terms. Well, but I also realized that the person apparently doesn't understand anything about repairs at all, how any of it works. He has this idea that he's already spent a lot of money, but in his opinion, it's a lot of money, so that's enough. After that, everything is supposed to just come together on its own. Everything's supposed to get done by itself. Well, it doesn't work that way. Also, the machinist had the engine for almost a month, give or take, with various complications and other issues. And in general, I won't go into all the details. You get the general idea. So let's move on to the engine itself. All the parts have already been purchased, and now my task is to assemble it as quickly as possible. I haven't done anything with the block yet. After the machining work, as you can see, they did the honing here. Apparently they used diesel fuel as lubricant during honing, so the engine still has some diesel metal shavings on it. So now I'm going to wash it again, blow it out, open up some areas, clean out some channels, check the threads, and then I'll start assembling it. I also need to work on the cylinder head. We have valves here. I think the exhaust ones are new, and we have valve guides. I'll actually start with the cylinder head, get that done first, and then move on to assembling the engine itself. I don't remember right now if I have any footage of this engine, but if I do, I'll insert it now. So, this is the condition of the grid. Well, the heat exchanger inside, our oil circulates here, and it's cooled by the coolant. As you can see, everything is completely clogged. I've already poked and scraped it a bit, but before that there wasn't even a gap at all. So I clean it like this, blow it out with air, and clean it again. I know for sure that I cleaned the heat exchanger, it was in this condition. Everything was like that, but I haven't really finished cleaning it yet. I soaked it, it's lying there soaking, and I'll try to clean it again. And also there's another detail about this engine. I have the oil pan here, so I was cleaning it. Here you can see the oil pan. I cleaned it, started blowing it out, and the paint inside here in the middle started peeling off. So the paint peels off from the air. It comes off in layers, in chunks. So I didn't risk leaving the oil pan like that, because maybe later the paint would keep peeling off. Nothing good would come of it. It could clog some channels or something like that. So I bought some paint remover, and now I'm going to cover the inside of the oil pan with this remover. and I'll try to remove as much of this paint as possible so it's just bare metal. Honestly, I don't like these painted oil pans. There are always a lot of issues with them. Alright, that's the plan. Let's get started. Also, there's one more thing I wanted to mention on camera, I forgot about it. I called the authorized service center to find out how much it would cost to repair this engine, and they told me it would be 220,000 rubles. The customer wants to do it for 60,000, but at the authorized service center it costs 220,000 rubles. So as you can see, there's quite a difference in price. But that they also told me that there's an option where they take the engine apart, inspect it, and then tell you what needs to be bought. So in that case, you need to pay them 60,000 rubles at the official service center. Just disassembling and inspecting the engine costs 60,000 rubles. So, I worked off camera, everything is already prepared. Now I'm going to assemble the cylinder head. So, I replaced the guides, cut the seats, lapped all the valves. The exhaust valves, as I showed, the exhaust valves go back in their original positions. That is, I have it marked, as we can see, the fourth upper valve, the fourth lower valve. And we can see that each valve has this kind of track, an imprint from the seat. Looking at the seats, we see the narrow working chamfer. Everything is recut and lapped. So, I've prepared the springs, retainers, collets and washers. I also removed all the studs completely from the head. The studs here are easy to remove and reinstall. I also have the sensors and the intermediate gear. So here I have new valve stem seals, and these little seals, they need to be installed. On that side, injector tube goes through them. Basically, you can't see them right now. As for the springs, you can see that some of them are marked with blue paint and others are marked with yellow. So the springs that are marked with blue paint are installed on the exhaust valves, like this, with the paint mark facing the head. And the intake springs are marked with yellow paint and are also installed with the paint mark facing the head. That's it. Everything is assembled. I tighten the head, all the studs, basically everything that's prepared on my table. I install all of it, assemble the head, and then I start assembling the engine. And So I've set the valves. Now I'm installing the studs and something else there. The puller, I have a 2108 valve spring compressor. I just drilled more holes here. Well, in some places you can reach, in some you can't. But basically on this head it was quite convenient. Well, in general, I'm working on the block. I just want to show you I poured in absolutely clean diesel. Meaning I washed this tray and poured in absolutely clean diesel. I cleaned all the oil channels here. Well, basically all the threads, all the channels, the holes, and you can see what the diesel looks like now. There are old oil deposits, soot and metal shavings. So that's how much more dirt I washed out of the block. So now I'm rinsing it in the washer with a solution. I'm using this kind of Reveso concentrate for washers. Now I'm putting the block in, washing it, blowing it out, cleaning out anything else, and then I'll get started. Subtitle editor. Alright, so the engine is washed, I've blown it out, and basically everything is ready. So I've already measured the protrusion of the liner above the cylinder block. According to the manual, it should be from 0.05 to 0.1 mm, which is 5 to 10 hundredths. Dial indicator, block is at 0, liner is at 10 hundredths, a tenth of a millimeter. Alright, next, well, 99.08, well, 98, 99.08, so also 10 hundredths. Continuing 9, I measured both sides and the protrusion is the same throughout. Also, according to the literature, the difference in the protrusion of the sleeves should not be more than 0.03 millimeters. Well, let's say this one is 0.10 millimeters. And this one is 0.06 or 0.05. So 0.05 is within tolerance, but all four sleeves should also be 0.05 or 0.06 millimeters. And if, for example, this one is 0.10 and this one is 0.05, the difference is already 0.05 millimeters. In general, gases can leak through, meaning either the gas will pressurize the system or escape outside. So in general, it shouldn't be like that. All the sleeves should be the same. And I'll also mention right away, before I forget, that this ISUZU 4HK1 engine is very sensitive to coolant. For example, I don't really know what this engine was running on, but you can see that it was running on water and not even tap water. It feels like it was from some swamp or something, as I showed earlier. I cleaned out all these channels with a drill bit, with brushes. I tried everything to clean them. Plus, I blew out an unbelievable amount of deposits from the water jacket. The heat exchanger was clogged. All the channels here were clogged, and then they even smeared sealant on top of that. So now I want to show you. You see these holes here? These are the coolant circulation passages. Well, of course, it also goes through the cylinder head. Something goes through there. Here we can see 4 holes like this. Well, and also from these holes, drilled passages run to these holes on the cylinder head's mating surface. Here we can see. Well, and these holes were completely clogged. Well, not completely, maybe about 80 or 90% clogged. The cylinder head was also clogged. So I'll repeat, this engine is very sensitive to coolant. You have to. Good antifreeze. If you don't want to ruin your engine like this, you need to use good antifreeze. So what am I doing now? So here I've prepared the second part of the block. This cover, got the bolts ready. The crankshaft is already polished and I've blown out all the channels. Here we have new bearings, main and connecting rods. Now I'm going to open them up and take a look, see what they're like. Here we have longitudinal ones, longitudinal. The crankshaft thrust washers are new. So I also washed, blew out and cleaned the oil jets. And these are the plugs that I unscrewed from the block. So the oil jet here is just a tube, a pretty good guide. Well, sometimes there's a little ball in there, and when you start tightening it, the ball turns. Here we see a real big solid guide so the oil jet doesn't twist. And also like this, there's a bolt inside, a spring, and the ball is set for a certain pressure. And for example, just cleaning these bolts. So I cleaned them several times with a special degrazer like this one. So I poured it all in and let it sit, by the way. Here's what the degrazer looked like just from these bolts. So I soak them, rinse them, then start blowing them out, and all this black stuff comes out again. Big flakes just fly out, and I do this several times. So just to clean these bolts, I also checked how the springs and the balls work now, making sure nothing is stuck. So just to clean this alone, it took me, I don't know, maybe half an hour or more, about an hour, yeah, plus the time I spent going back and forth and so on. So this is about why engine repairs take so long. I'll say right away, I don't know how to fix engines quickly. I need to pay attention to every part, every single part. I need to inspect, wash and blow out each part. I've also blown out the engine block several times, checked all the passages with a flashlight and inspected everything. I turn over the block, unpack the bearings and install the crankshaft. Then I'll move on to the pistons, they're over there. We'll also take measurements of the pistons. According to my calculations, there shouldn't be any need to trim the pistons. We should have between 0.4 and 0.8 mm there. I think we'll be within that range. I expect it to be around 0.5 or 0.6 mm. Well, let's not guess. I'm just thinking out loud here. Let's not guess. We'll assemble it, take measurements, and then see if we need to trim the pistons or not. Alright, that's the scope of work. Let's get started. So there are thrust washers in the set. There are only 3 of them. So 2 rings are installed on the flywheel side, these ones, and on the opposite side only one ring is installed in the block. And as we can see, there are grooves here, so you can't install it any other way. This side is steel and this side has the anti-friction coating. And it turns out on this side we also have slots for lubrication. And to make sure you install it only this way, not the other way, these tabs are made in different sizes. So you just insert it right here like this. Alright, so I'm installing the plate. I've prepared everything. The bearing shells, a bit of assembly paste here, and a very thin layer of sealant around the perimeter. I'll put it on now and wipe off any that squeezes out. So that's it. The plate is ready. The block is also prepared. Everything here is degreased. The crankshaft is installed. And there's also a bit of assembly paste. Here's the ring, well, the second thrust washer. I also held the thrust washer in place with grease so it wouldn't fall out of the plate. So basically I'm installing everything. So I just started it with the gun without tightening. Now I'm going to tighten it. First we tighten to 90 Newton meters, then 130, and then turn it another 60 degrees according to the manual. So for the first pass, my wrench is set to 90. Next 130 then. Alright, 126. 130, well, give or take, the book says 132. So now I'm making marks so that they're along the length, as usual. But this time, I need to make them not across, but at about this angle. I make a mark like this, and then I make marks along the length for the angle turn. Alright, as we can see, the crankshaft is tightened, everything is great, it turns well and smoothly, and the end play is also just fine. Now I'm installing these additional clamping bolts around the perimeter. So here we have new pistons, piston pins, retainers, piston rings. One box is already open. Well, I took measurements when we just brought it, after we bought it. Basically, I checked if those rings were the right ones, put them on the piston, measured the gap, and here we have the connecting rod bushings. We gave the pistons to the machinists, and I also unwrapped one pin, which we also gave to the machinists. So now I'm taking out the connecting rods. The connecting rods were also machined. I'm putting one piston without rings onto the connecting rod, and I'm measuring the piston protrusion above the cylinder block. And then I make a decision. Either I leave it as it is, or I'll have to trim the pistons. Alright, so I've installed all 4 pistons. I've already taken the measurements and now I want to show it on camera. So I set the dial indicator so that the block reads 0.
Let me find the easiest way to do this.
Here the dial indicator block is at 0. Alright, I'm turning it. 10, 20, 30, 40, 50, about 56. Let's see. The second piston. Well, basically I first took measurements of the second piston because they move together. So it's hard to measure them, meaning I measured them one at a time. Now I'll show the first one on camera as well, the first and the fourth. They move separately. So we can see 0, 10, 20, 30, 40, 50. Well, about 50, a little over 50. 253 that. So we have from 0.45 on the first cylinder to 0.55 on the fourth. Well, these are about 0.5, so there's a small difference, but it's not critical for us. It doesn't really matter much. So about the gaskets. There was a standard gasket here with a thickness of 1.47, 1.475, well, roughly 1.47, right. And the thickest factory gasket available is thicker by 1/10, 1.575. Right. We removed 0.12 mm from the block and 0.05 mm from the head. So together that's 0.17. Well, 0.16, 0.17. So basically the dimension only changed by 0.06. According to the literature, the piston protrusion is up to 0.67. So well, almost 0.7. And there, if the protrusion is 0.67, then the thickest gasket with 2 holes is installed. Well, I'll show you the gasket with 2 holes later. Here. If it's from 0.5 to 0.6, then a gasket with 1 hole is installed. But we can't install the one with a single hole, because we also have a gap in the timing gears. So, well, as I see it, everything should be fine. The gear should fit with the repair gasket, and here the gap will literally change by about 0.05. That's why we'll use the gasket with 2 holes, the thickest one from the factory. Well, of course, there are also homemade ones up to 2 mm, but that's a different story. Right now, I'm talking about factory gaskets in SPI. So we install the thickest factory gasket, which is 1.575 thick. So it turns out that the piston protrusion with this gasket is even less than it should be. That is, it should be up to 0.58, but we have 0.45 to 0.55. With 2 holes, it's from 0.58 to 0.67. So we install the pistons as they are. Now, I'll take them out, install the piston rings, put the retainers back in place, lubricate everything, and then install the piston assembly. Then I'll work on installing the front cover, the rear cover, the oil pump here basically. I'll do everything as I go. Before installing the piston rings on the pistons, I check the ring end gap. That is the gap. I take the rings, insert them into the liner and take a look. This is our oil control ring. I align it. 0.25. Yeah. 0. Yeah, it's going in a bit tight. The oil control ring gap on this engine is from 0.2 to 0.4. Here we have, as you can see, 0.5. Everything is great. Now the compression ring. The top compression ring should have a smaller gap starting from 0.18. So from 0.18 to 0.4. Also, according to the manual, the maximum wear for the piston rings is 1.1 to 1.2. Well, that's if you're installing used rings. Well, here we have 0.3 men. It's going in with difficulty. So that means there's also about a 0.25 gap in the upper compression ring. And the lower compression ring as well. Here we also have about 0.35 mm. Let's take a feeler gauge. Here you can see 0.35 mm fits tightly. That's it. I've checked the ring end gaps. I'm installing the rings on the pistons. So we put on the oil control rings first, then the compression rings, starting from the bottom one. So it's impossible to mix up the rings. Each one has a different profile. For example, you can't put this ring here anymore since each ring has its own profile. So since we have 4 rings here, well, we space them 90 degrees apart. I try not to put them on the piston pin. That is roughly like this, so that they're not on the skirt or on the pin. So, well, like this, at a 45-degree angle in relation to the skirt and the piston pin. I spread them at a 45-degree angle, so the piston rings are being installed. There is a mark on each ring. Here, for example, there's the letter M. Here. We place this mark towards the piston crown. Like this. This is the piston crown. That means all the marks face that way, towards the combustion chamber. Alright, I've set the rings. Let's check that they move freely and aren't getting stuck anywhere. That's it, this piston is ready. Now the same for the other 3. Alright, that's it. The main and connecting rod bolts are tightened. I already mentioned the torque for the main bolts. Now let's tighten the connecting rod bolts. I tightened them to 50 Newton meters. Then 2 turns first, 60 degrees, then another 30. So the same 90 degrees in total. So 60 plus 90 degrees. That means each connecting rod should move freely like this. It shouldn't be tight. This is a must. If it's tight, then something is wrong. Either the bearing is installed incorrectly or the caps are mixed up. Well, in general there is some reason for it. So, for the connecting rods first, second, third and fourth, I marked them, made my own marks. Well, and also on this side there is a mark both on the connecting rod body and on the connecting rod cap. Everything works out. The main and connecting rod bolts are tightened. The piston assembly it's a bit inconvenient, such an adjustment to install. One of the edges tends to slip in there along with the ring. So carefully, without much force, without heating. That is, I carefully put the rings in. That's it. The pistons are installed. Everything is tightened. Now I'll close the front and rear covers. Well, first I'll install the timing mechanism here, some gears. Then one gear is installed only after the cover is in place. So, and I'm also closing the front cover. Well, I don't know. If it works out today, I'll install the oil pan. Basically, the cylinder head is ready and I can install it. So, things should start moving along now. So, I've also already checked how the oil jet lines up with the recess in the piston. We can see, I'm not sure how well it's visible on camera, but where I'm shining the flashlight, there's a hole and the oil jet is right in the middle of that hole. Here as well, it's right in the middle of that hole. I'll turn it more and show you the first and second ones. Here. So the first one, as we can see, the oil jet is fine. Nothing is touching anywhere. Everything lines up. And also the fourth one. We can also see that everything is fine. So the oil is spraying from the oil jet right into the center of the piston. There is a cavity made there and oil from the oil control ring also gets in there. It scrapes it off. Well, and then it drains. So on the opposite side there is also a hole in the piston. And through this hole we also have something happening. Some oil leaks out. So basically that's it. The crankshaft is in place, the crank and rod assembly is in place. Now I'll also check the caps to make sure the connecting rod number matches the cap number. That's all as usual. We don't need to check the main bearing since it's a solid casting. Alright, so I'm installing the timing gears. I put in this idler gear first. Its shaft is secured with 3 bolts with thread locker. I applied thread locker everywhere and I also tightened this bolt with thread locker. So as you can see, everything is great. You could say it's perfect. Next, I'm installing this shaft. I was sitting here looking at how the lubricant gets in here because there's a channel here. There's also a channel here. It comes out from the side, but there's no channel anywhere here. It turns out that this part has a certain height, it rests here, and basically there's still a gap left here. And the oil gets into this, well, this cavity, and then from this cavity. The bolt here doesn't sit tightly, as we can see. The bolt has some play, and the lubricant passes between the bolt and the bushings themselves, comes out here, and we already have it on the gear bushing. So I'm installing this shaft. I'm also tightening the bolt with thread locker. Well, here you need to align the marks. Honestly, Yoram, I don't really understand the point of these timing marks on a common rail system. They are set according to the flywheel and the camshaft Standovitsu. Just like, for example, on a Volvo D12, the camshaft is set the same way there. So the crankshaft is set to a certain position, top dead center, and the camshaft is set according to the mark. Here basically it's the same system. We can just set the crankshaft to top dead center and then set the camshaft according to the mark. But since there's this mark here, of course I'll align it, of course I'll set it. I just don't quite understand what it's for. One possibility is that this engine used to not be common rail, but let's say just had a fuel pump. In that case, yes, then we would need all these marks. So here on the crankshaft we see the letter L. Somewhere on this gear it should be. Yeah, here they are. So, I think I rushed installing this gear. It seems like the pump needs to be installed first, so the oil pump will be new. I'm unpacking it now, and let's see in what order things go. Either the pump first, then the gear, or maybe I can install the pump now. So, I applied assembly paste to lubricate the gears so that these bushings installed in the block are also lubricated. I checked this valve. It's just a ball and a spring here, so it's a relief valve. I checked it. It moves and works fine. So now I'll degrease this area and then I'll apply a very thin layer of sealant here. Just about a tenth, really just a thin layer. I don't know. Maybe even just a few hundredths, not a tenth. So everything is installed and tightened here, and these are the gaps. Somewhere around 10 to 15 hundredths in this range. All the bolts are tightened. I checked everything again, used thread locker, installed it, and inspected all the threads here. So this is the oil channel going to another intermediate gear. It's installed here. This is the shaft. The bolt secures the shaft of this gear. And on the housing itself there is a groove. The oil also flows through that groove. And then between the bolt and the housing, oil also goes to the gear shaft. So I checked everything here again to make sure I can close it. I didn't forget anything. So now I'm going to close the flywheel housing. The housing is already prepared. It was also machined. Because this is the surface where the cylinder head attaches. Well, I showed all this earlier. So I blew it out again, degreased it, applied a thin layer of sealant here. It seals without a gasket, just the sealant. Here's the channel I was talking about.
So the oil gets in here, then into this hole, and then onto the shaft. The oil seal is installed later. These oil seals here are kind of damaged. I call them that. I don't like them. I prefer the marked ones. I really can't stand these at all. There's a special tool for installing them, but we'll get to that later. I'll show you. So I tightened the flywheel housing bolts, and here I installed another bolt that's behind the gear. I tightened it, marked that it's already tightened, and then I installed the gear. Also the shaft and bushing, lubricated them, installed and tightened them, and now I'll be putting on the front cover.
So I've prepared the front cover. The cover is different. This is the cover from this engine. Look at this corrosion. The aluminum is eaten through completely. Here. Well, in general, you can see what condition it's in. The cover is used from the same type of engine. I washed it, cleaned it, got it ready. I installed a new gasket here. There's a bypass valve in the block. And here we also have an oil channel. The valve is on this side. I also removed it. Well, I inspected it, cleaned it, blew it out and lubricated it. Installed it back in place. Prepared the bolts for the front cover. Here I opened the set of engine seals. I checked which ones go where. Here we can see there's a gasket for the oil channel here and another gasket for the oil channel here. I'm installing the cover. Well, the oil seal is just like on the rear cover on the flywheel housing. The oil seal will be installed later once the cover is in place. There's this kind of valve in the block. I also inspected it. I washed it, blew it out, lubricated it and checked how it works. So basically there are no issues with it. Alright, so next I'm installing the oil pickup. I also washed it, of course, and blew it out. I've already installed a new gasket here. I've prepared the bolts. So I close it up, install the pickup, and then install the oil pan. Just like this, these two bolts go all the way through. They secure both the pickup and this plate at the same time. And here we just have a single bolt. I'm installing the oil pan. Well, I guess I'll flip the engine over. I'll install the cylinder head right away, since it's already prepared. Well, then I'll start with all the accessories. I'll assemble the fuel system up front. Oh, I also need to install the flame start heater. So for now the oil pan, the cylinder head, and then everything else as I go. So I'm working on the heat exchanger again, the radiator, the grill. I started blowing it out, took it out of the wash, started blowing it out. Black stuff just keeps coming out of it. I've already washed it in the washer and soaked it in diesel. It sat in diesel for days. I poured in fresh diesel, drained it out. Several cycles, more than 10. The diesel looked clean at first, so I put it in the washer and started blowing it out. Then black stuff came out again. Right now, I'm pouring in a special degreaser. Well, like this one. Here I'm pouring it in and it's soaking. And then I drain it. And I don't even know how many times this black stuff just keeps coming out and coming out. There's even some sediment there, though my container was clean. We can see the sediment. And honestly, I probably should have just installed a new radiator. But now I won't say anything to the customer about this. It is what it is. I mean, I'll clean it as much as possible and install it as is, because the customer only sees it one way. You're deceiving me. I have no other choice. You're just taking my money. So, not only has he not paid for the parts yet, but the parts guy had to front his own money. Well, because no one gives you parts without payment, the engine still needs assembly and the client keeps calling. And with, well, basically constant complaints, at least don't spend just 10 minutes a day assembling the engine. Spend at least an hour. So, in his understanding, I'm just sitting here doing nothing. That's why everything is taking so long. I've been working only on his engine for the second week now. Nothing else. I'm not sure, maybe yesterday Sunday. I left here and headed home at around 11 p.m. Well, and then the client calls. The first thing he says is, "This engine cost me a lot. A golden engine. I'll call it the golden engine." Why is it taking so long? My engine has never taken this long before. I don't know. The customer is dissatisfied with timing, cost, and everything else. Well, I'm not satisfied with anything either. Honestly, I don't even know why I took this engine in for repair. Actually, it turns out I wasn't actually the one who took this job in. I was just told that the engine was already at the transport company. I have to do it. And then there were constant reproaches. Why is it taking so long? Honestly, I regretted taking this engine in for repair 100 times over. So, I just want to show on video where the time goes, where the money, materials, and so on are spent. That is, how many consumables I used up here just to clean this heat exchanger. So, and if you also consider that it was completely clogged right here, where we have antifreeze, where the coolant flows, inside it turns out it was completely clogged. I think the oil wasn't passing through it at all. It was going straight through. There's a direct channel and a bypass valve if the heat exchanger is clogged. The oil goes right through. I'll wash it a few more times. I'll leave it to soak until tomorrow. Well, I'll go and put the oil pan back on the engine. The most interesting thing is that it's coming out in these flakes. So it's all clogged up in there, as far as I can tell. These kinds of flakes, and they dissolve and turn into this black stuff. So I don't know how much I'll be able to clean this heat exchanger. Of course, I'll keep working on it as much as I can. But honestly, it really needs to be replaced. But as I already said, I won't even mention this to the customer to listen to all this whining again. I don't want to. So, some time has passed, one way or another, but I really want to show on camera how clean I managed to get this heat exchanger. I've just poured in fresh degreaser. It's been sitting here with it for a while now. Continued. So you see, right? Absolutely clean. So now the heat exchanger is as good as new. Basically, I spent a lot of time. I spent several thousand rubles on various cleaning chemicals, but still I cleaned it.